Thank you, folks, for being here. As I said, doors closed, so there's no way out anymore. But today you're going to hear an interesting story, the story about one of the most embarrassing moments in my professional career. So the story today is about Metabot, how we built it, how it broke, how we could have avoided it, and what we did in the meanwhile to recover from that disaster. So Metabot is an AI analytics agent which is built on top of Metabase. So not everybody might know Metabase. It's a business intelligence tool, and Metabase has a huge focus on self-serve analytics, which means there's a couple of folks who don't speak SQL, and we want them to have a way to navigate through their data, answer their business questions without always being blocked by a data person. It doesn't always work. It also depends on how your data looks like, obviously, but that's the plan. Then with all the developments that we recently saw in LLMs, these large language models, talk to your data, there was a lot of stuff going on there. We were very excited to also explore that path a bit more, because if it works out, it's actually something that could help us a lot to even further improve the self-serve capabilities of the tool if folks can just like talk to their data, basically. So last year on our company offsite, we started to build Metabot. So a small prototype, on a hackathon to see how things are going. And to be honest, that version was still rather duct taped back in time. And it worked quite well for the happy path, but we might all know that users also quickly wander off that happy path. So when we started building Metabot, the first challenges that we actually had to face was, how would we integrate that thing into Metabase? So what you see out there with the tools around and a couple of startups popping up is that a lot of folks just go for the chat window. So there's a dedicated page where there's some chat. There's an agent that might have certain tools to discover your data, to search available data sources, and to analyze them, query them in a way, and then later visualize them. However, we wanted to go one step further and integrate this more into our product. So the idea was to create, start with a chat interface as well. So that was the cool stuff you did back in time, right? And make this chat context aware. Which means when I'm looking at a dashboard and I'm asking questions about it, that the LLM would know about this thing and would be able to answer those questions. It should also be able to navigate me around in the app and just know about what I'm looking at and be able to help me out there. So think about it like a data buddy sitting next to you, helping you to navigate Metabase, to query your data and find answers to your questions. So another thing that we wanted to do is that we intentionally did not want to create SQL. The problem with SQL is that if you cannot read it, you also cannot validate it, right? So there might be a query, you get results, everything might look super fancy, but the question is how trustworthy is it to me, especially if I don't understand it. And in Metabase, we have this query builder, which you see on your right-hand side. This is basically the way for like the non-data savvy people or non-SQL people to click together their query. And they, as you see here, they would see what kind of filters are applied and how does this thing roughly look like. So it's a bit easier for them to understand what is going on there. So they have a way to validate it, at least to some extent. So yeah, we built Metabot on the hackathon. It worked out quite well, surprisingly well. And then we got a huge buy-in from the company, from the CEO. So we decided to build this thing for real. Now, a couple of weeks in, so we had some first struggles, like folks needed to learn how to interact with LLMs. It's a bit of a different way of engineering, right, than writing normal code. So folks needed to learn that first. We struggled a bit on some things there. But then the dots were like slowly connecting. And it felt like we're actually building something that could make a lot of sense. Then I went off to a conference and came back after 3 days. And then the CEO approached me and said, hey, what's the current state of Metabot? I want to get a demo and see how it's going. Yeah, since I was super excited on what we built so far, I pulled the latest main branch, started Metabot, and started with a couple of test prompts to see how it's going, and then everything broke. So Metabot turned into some super weird, confused intern that was very eager to help me, but it couldn't understand what tools it has available, how to use them, how to create queries. So it was just super, super useless. Obviously, like this was not a nice moment. So very embarrassing for me, one of those most embarrassing moments in my professional career. And our CEO was also not very amused about that. So what did go wrong? we looked at stuff, and I think one of the core problems that we identified was that we tried to optimize too much on the local problems that we have been building for. So you can think of this, there was maybe some person working on this context awareness, another person working on the querying tool, and then the querying tool person maybe was super optimizing the tool description, the parameters, the system prompt, and all the context that's around there for especially this use case. And then sometimes, as engineers, we make this mistake that we look too much inside our box and we don't look outside of the box anymore. So the tools individually might have worked, but as soon as the things connected later, things fall apart. Because when you work with LLMs, you need to see the whole picture, the whole context that they see. Otherwise, you might create a very, very confusing environment for them. So what we did afterwards was that we said, okay, let's try to prevent that. Let's try to build a benchmark that we can run. So when I optimize my querying tool and I would run it against the benchmark, I might see if something else breaks somewhere in the benchmark. So it is at least some kind of a test indicator for me that something is off. And then we happily started optimizing for the benchmark. This is what you do, right? So you want to get better and better on the benchmark. But the problem is, I think as soon as you are in the 70s and 80s of a benchmark, from a score from 100, then things start to get weird. And I think we all have experienced that if you looked at the latest and greatest LLM announcement, where every new model is higher on the benchmarks, and then you suddenly, when you play with it, it feels kind of not that intelligent, and maybe even worse than stuff you have been using before, right? So that's a problem we see in the industry as well. And we saw this as well at Metabase, where suddenly, when we started optimizing for the benchmark, there was a big gap between the perceived performance, so when I'm playing with this thing, versus what I actually see as a score on the benchmark. So benchmarks can be helpful, but I would not recommend over-optimizing on them. So take them as kind of like a measurement indicator, whether you break something, and also how you're progressing, but don't take them too serious, because I think this is a real hard problem to solve on creating a benchmark that really matches your perceived performance as well. And as you see this, we have this problem in the industry as well with the big providers and the benchmarks we have out there. The other thing we realized was that actually what we're building is not a querying agent or something. So the value that we are generating is how we pack this context together and provide it to the LLM, so that in the end the LLM does the right thing in its next step. So a key tool that we used there very early on was that we said, let's try to create one centralized representation of data assets and things that we show to the LLM, that we have some reusable building blocks that's actually that are optimized for the LLM. So we have a couple of internal APIs, external APIs, and I think the LLMs are also getting better in using those with MCP and so on. Most of the times, MCP are also just wrappers of APIs with trying to make them a bit more usable for LLMs. But we found that those internal representations can be very helpful because you can optimize them rather independently, not fully independently, and then one person optimizes them and the other can benefit from that. And one example I give you here is just some random code, how things could look like. So think about a table, and we want to represent that table. Then you will see things like maybe wrapped in XML text. You see a couple of metadata as a text template, and then maybe a description and some information around the fields that are there. And now we can use this building block, this LLM representation, take it and reuse it for all the tasks that we have. So if somebody is working on the context awareness, and let's say a user here is looking at some saved questions, so we call those saved questions, basically that's the visualization that you have, you save it and in Metabase it's a question. So somebody's looking at a question, and maybe this question is based on a certain table, and then when I'm working on this context awareness, I can fetch the metadata of the table, and then down here you see that we would maybe use some kind of a string where we say, okay, the user's looking at the results of the rows of a table, and then we reuse this table LLM representation in here as well. So it's a nice building block that we can use across the application, and it makes it easy for you because when you're building those things, you don't need to think about what's the best of representing the table, that somebody else can take care of that. Another interesting thing, and Alberto from Shopify also mentioned this in his talk before, is around tools. So I think it's almost common knowledge already that we say when we do tool calls and there's an error, then we should provide some meaningful error message to the LLM. So how would you resolve that? And not just dump the raw API response error that you get somewhere. So I guess that's kind of common knowledge, but what was very helpful for us was actually applying the same technique on successful tool results. So when you have a tool result, you can still give some instructions to the LLM on what to do with it. And I also brought you an example how this could look like in code. So in our case, we have this instruction result schema where you can basically provide data and instructions. And then things would be also, in this case, wrapped in some XML tags. So like those representations, by the way, they could also be optimized per model, whatever you use there. And then this thing could look something like here below, where the model created a chart, and then we say, hey, chart has been created, the chart has the following ID, and then some instructions where we say, hey, by the way, the user is currently not viewing that chart yet, but you can show it to them by navigating them there, or you can reference the chart as well in your markdown response. And then this weird link format that you see down here, that might be something that's already also in the system prompt, but when you nudge the model in this, like, when you provide the context just in time when it's needed, then it actually helps the LLM follow the instructions way better than if it's somewhere hidden in the history or in the system prompt. So that was something that we found that helped like improve at least the perceived performance a lot, where you see like it's really following the instructions now way better than it did before. Another maybe rather controversial slide, a bit spicy, is something else that we figured out. So there's a couple of techniques how you can do data querying and stuff. I guess the most simple thing you can think of is just dump everything into the context window and let the LLM figure out what to do. And what we discovered when we added more tools for the agent, that it could, for example, search the data sources, get metadata about the table, get some maybe field fingerprint on how the field values look like, and so on, that it actually got way better than before. And now you could argue, okay, but there's a couple of tool calls that it needs to do, and there's like always room for errors there, and I would like agree with that. But what we saw in the perceived performance is that the LLM actually also got better in clarifying. I'm not sure why this is the case. Maybe that's like something in the training data, even though I think in the training data we also often have the issue that we don't see those training cases. So it's mostly like question, tool call, tool call, tool call, and then a result. At least that's my assumption. Whereas there's, I think, very few cases where there's some tool calls and then clarification in between and then maybe going on. But at least for our case, this was something that the stepwise discovery actually helped us also make the LLM a bit better performing as an analyst. So after a couple of weeks building and trying to clean up our disaster, we were ready for the user check. So let's see what happens if we bring this out to real users and what kind of challenges we would see only then when you give this in the hands of others that don't know how this thing should be used. And there's a couple of interesting lessons, more than I can put into these 20 minutes, but I just want to share a couple of those with you. So one of them is that Metabase is open source. So we have a cloud-hosted service, but a lot of folks also want to self-host us, even if they use the paid offering with additional features. And you might find setups where they are totally air-gapped, so no connection to the internet at all. And this means you cannot just use the latest and greatest model behind an API, but you need some way for those customers as well to self-host their models. So we might need to have an eye on open source models. And if we maybe play with the super crazy good API models, then we might maybe want to use a few generations, some models from a few generations back, to have something where we can compare it to the open source version as well. Another interesting thing that in hindsight is somewhat obvious, but I also found it interesting, is latency. So I think by now we know streaming is almost a no-brainer, so you can bring down the perceived latency, because then something is happening and it doesn't feel so weird to the user that there's 14 seconds and nothing happens. And when you think about the reasoning models, then you have a similar problem. So reasoning models, some of them reason just for a short time, but it might be that some of them also reason for 2 or 3 minutes, and you don't see a lot happening. You might be able to provide the user with its thinking and maybe a bit about the content. But it's a very weird experience if you have this live interaction target where this data buddy should sit next to you, and that can be a problem. It's totally not a problem if you have an async task. So let's say I want to know why my page views dropped by so much last week, and I let an agent go off and analyze this and then come back after 3 hours and send me an email. But if I have this live interaction, then this is also something where latency becomes a real problem. So this is also something that limits the choice of models that you can actually use for the agent that you're building. Where things get more interesting is if you connect the agent to real production data. So we might have our example user here asking something about customer churn. And we all know our LLMs, they are always super eager, happy, friendly to help us. So they would go off and check our data warehouse. And the problem is that our data warehouses don't look something like this, where everything is super tidy and well organized, but the reality is more something like that. So you will find a huge chaos. There might be tables lying around that are legacy you should not use anymore. There might be tables that are from a temporary analysis that you should also not use for your normal data analysis. If you're lucky, there are a few tables that have meaningful names and a description. If you're even more lucky, the columns would also have descriptions. And if you're even more lucky, those descriptions are actually meaningful. And the orders table doesn't say this table includes orders. So you should have some descriptions that also tell you what should you use this table for, what should you not use it for, what's the granularity, like all those types of questions are usually not asked by the type of data that we see from our production customers. Another big problem that comes on top of that is that we humans are super bad in providing context. So I guess a lot of us might have experienced this, where you have like a conversation in Slack. Based on that, you go off, you do a task. After 3 hours, you come back just to realize that you actually totally misunderstood the question. And that's the same thing that happens to LLMs. We just are even worse, I guess, when we talk to LLMs, that we provide all the context that it would need to fulfill the task. And all this kind of ambiguity and missing context is a real big performance killer for LLMs. So the mental model that I always try to use when it comes about how AI ready are you is that imagine you hire somebody freshly, they have the first day at your company, and if they can't navigate your data setup, then probably an LLM also has a really hard time. And the folks from Mistral actually have been talking about this on the first day as well. So my prediction is that this type of problem, this garbage in problem that we have, is one of the next big challenges that we need to solve as a community, because we can build the crazy best AI agents, whatever, but if you have a really bad data foundation, they won't get anywhere. So maybe we can use them to actually improve the data foundation, teaming up with humans, but I guess we could at least get rid of 70% of the annoying work there and maybe support the humans there as well. So that's like one of the things we also have in mind, where we could potentially help a lot and kind of get folks more ready to actually use their data in a proper way. Something that we also often don't think about is just to simplify the problem. So we're always super eager on like solving the crazy hard problems, and maybe for a data analyst bot, this might mean to always like create a new query, it should always be right, and so on. However, we are a BI tool, so there is a lot of existing stuff already there. And there's a very high chance that someone in your company might have had the exact same question that you had. So why not just use what's already there? And that's also one strategy that we learned, that it actually makes a lot of sense to just like make this thing available via search, because if it's answered already and there's a dashboard, why not like move the user there first before we start going down this very error-prone route of querying the raw data eventually. Another thing that you can do is just simplify the problem by like good docs, as I said, but you can also put another layer on top, where we try to create something like a semantic layer, so where there's a couple of predefined metrics. So I would define as a data person how we calculate revenue in our company, and then there's a revenue metric with a couple of dimensions that make sense for a breakout here, and then you reduce the problem space by a lot. So it might be that you don't have 1,000 raw tables you need to choose from anymore, but maybe just 50 metrics. And those 50 metrics can already answer a lot of business questions that the users have. So also keep this in mind when you want to build AI analytics agents, having like some kind of a layer where there is some predefinition of certain metrics that are important, that can actually help you boost the performance, because it's just like a simpler problem to solve. So if there's anything I want you to take away from this talk, is that you should not build for the happy path. Try to build for the chaos. We have enough happy path demos out there, and every day there's another startup popping up somewhere that shows like how crazy good the AI product is. But in the case of analytics, we also did this happy path demo on our hackathon, right? But there was 5 tables, everything well described, but this just doesn't match reality. and the users wander off that happy path so quickly that everything that happens eventually is that you just create huge expectations that everybody's very frustrated when they start using our products. So let's not always build the happy path demos only, but try to make sure that we build for the chaos. Remember, benchmarks can be helpful, but they can also betray you. Always keep in mind when you're building things to see the big picture, like think about the context that eventually reaches the LLM. Think about like your human mental model. So like, can a human use that stuff that I'm working with or not? That's usually a pretty good approximation for how the LLMs would feel when they work with that stuff. And expect your users to be super weird. So they might even be weirder than the LLMs that we are using sometimes. So I hope that content has some couple of things that might help you building your AI agents, a couple of learnings that are interesting. I'm also happy to dive way deeper into stuff later on. And if we have a couple of questions, I'm also happy to take them. Thank you.